Hi, everybody, and welcome to Tremco Live, where we're socially distant but technically connected. I am Marcy Tyler, the Director of Building Science for Tremco, and I'm joined once again by my co-host, Paul Hugenboom.
And I'm the president of Tremco Construction Products Group, Marcy. Of course, you know that. And a fine collection of products, brands, companies, and of course, most of all, people.
Exactly.
All over the world.
You know, Paul, sitting here with you on Fridays, we've been doing it, I think, 83 times so far, so yeah. Not a bad number.
No.
Not a bad number. And if you guys recall, this is all about connecting with our customers. So when Paul mentions, it's all about our people, that's our people here, that are part of our organization. And of course, all of you, that's part of the industry. We really do love this time to engage with all of you and wind down your week with us.
Yeah, the big catalyst, Marcy, right, was, COVID came along, and we, of course, loved to host people in Cleveland. Yeah. And you and I got together and said, well,
gotta do something.
Gotta go virtual.
Let's do something. So that's where the Tremco Live all started many months ago now. So welcome everybody. We are in the month of December, and if you missed us last Friday, we had 3 people on as a panel. We talked all about building commissioning. So it was a really great, lively discussion. So as always, you can catch that on YouTube. So it was just, I thought it was great walking through as we look at new construction, all of the things that we need to verify as it relates to performance and how critical those are. We had a lot of great dialogue associated with that.
Yeah, and I think that the key thing I took away from that was just get commissioning right up front, right? As opposed to somewhere later in the process, right? And that was probably the biggest takeaway from our presenters was just involve us up front, and things will go better.
Absolutely, and that's true for everyone that's going to be involved in those projects, right? So that you can get up front and have those discussions as early as possible. One of our colleagues, Mike Siebold, gives presentations often, and he always talks about being able to control things up front, right, of that project, and it's a lot more efficient if we handle them up front versus much later on.
Yeah, I learned from Mike that up front, everybody always thinks aesthetics. What does it look like? And again, last week was, performance up front. That's important too.
That's important. Well, so as I mentioned, we talked about commissioning, and a lot of commissioning, most likely it has to do with new construction and how we go about, monitoring performance throughout the construction process and then into the use of the building. Today we have a guest that's going to talk to us about existing buildings. So very excited to bring Craig Stevenson on Tremco Live today. Craig, welcome to Tremco Live.
Hi, everybody.
Hi. So Craig, you probably don't realize this. In previous Tremco Live episodes, ever since I met you, I've mentioned you in terms of one of the things that caught my ear when I heard you present about your book was that with existing buildings, we aren't utilizing them as we should. We're basically letting money go out the window, right? So we're not monopolizing what we could be in terms of the performance of our buildings. So I'm excited to have you on here so you can talk to us a lot more about that. But why don't you introduce yourself and tell us a little bit about your experience in the industry.
Absolutely, thank you very much. Are you guys able to see my screen?
Yes, we can see it, perfect.
Thank you. Thank you for the opportunity to speak here at Tremco Live. We love working with Tremco. They're a great resource partner when you want to deal with high performance buildings. There are a lot of manufacturers are starting to look at this space, but Tremco is really in it right now. So when you want to start talking to them about materials and alternative materials and how to use that to drive building performance, these guys are a great resource. What we're going to talk today about is a book that we wrote last year. It was published in November with Island Press, and it's available at all outlets. It's called The Power of Existing Buildings. So my background is I basically grew up in the construction industry. I came out of college and I worked for a general contractor, and I built buildings for about 25 years. And we were an early adopter in sustainability initiatives and practices. And I just became frustrated with greenwashing and actually not seeing the buildings performing as they were intended to perform. So we knew there had to be a better way after that. After devoting my entire career to building projects, we know that there's a better way to do this. So we started, I developed Oros Group about 6 years ago, and Oros Group focuses on the intersection between building science and data science. We believe when those two things converge, we can operate buildings at high performance levels for the life of the buildings. And we're going to talk today about that. Existing buildings, the reason why we devoted our book to that is because that's where all the value's at. We have these buildings that are underperforming in the marketplace, and when we can transform them into high performance buildings, it turns it into a real asset, not just operationally savings of cost, but also from a building occupant perspective, and getting at it using natural triggers. So again, we're going to talk about that today. As I stated before, Oris Group focuses on building performance. That's what we do. We are certified in all these sustainable certification programs that exist, but we take an evidence-based approach to projects, and that's made all the difference. When we do that, we find that we can pretty much certify in any of the sustainable programs because we're taking a direct route to high performance buildings starting in the planning stages. So as I said before, this is a copy of the book. It's called The Power of Existing Buildings. Sorry, late in the day, I can't speak today. But it's just a guide towards how do we get there, and at the end of the day, how do we prove that the buildings are performing as intended. So we talk about doing this in practice. So starting here, typically in traditional construction, we have design, construction, and operations, right? That's normal. Most of the times, that's something unusual, or it's not unusual for people to look at and say, yeah, that's how we do it. But when we talk about setting goals, we talk about doing this using evidence-based criteria. So we do design charrettes, and which leads to a metric-based owner's project requirements. I'm going to show you an example what that looks like today. And at the end of the day, we want to measure our performance, but we don't want to measure it by just simply throwing $1 million at our building and putting a meter on every outlet. That doesn't do anything for us, right? If we set our goals based around energy performance for site EUI, source EUI, total cost, and carbon, then we want to make sure that our feedback loops are telling us whether or not we've achieved the goals that we set out to prove. So this is really kind of what it looks like, and the difference is we take a different approach to setting goals and measurement and performance. And this is what it looks like when we're done, right? So when you look at a dashboard, for example, and you see the consumption of energy, electric, gas, or even water, and then you see temperature and humidity and CO2 off of monitors, we don't always have the right context, right? So data scientists are going to tell you, well, the building's performing better than it was last year or better than the average of the last 5 years. And you look at this and it doesn't answer the fundamental question. Is the building performing as it was intended to perform? The only way to answer that question is to look at the dashboard with regard to simulated performance. We can simulate buildings in a very highly calibrated way to 1% of performance. And we use that for monitoring-based commissioning and interrogation-based commissioning. We use technology to drive performance, and it gives us context. So now we don't need to look at historics. We can look at the actual intent of the building and what it was supposed to do. And we can do this for all forms of energy, and we can do this for temperature and humidity and CO2. So when we talk about measurement and performance, it's always with the context. Just don't show me kilowatt hours, because then I don't know if the building's good, bad, or indifferent. Don't show me an EUI, because I don't know if that EUI is contextually accurate in terms of how the building should perform. I want to see it in the context of how it should be performing, and that's what our owners are demanding from us today. So when we talk about that, let's look at where we've been and understand where we're at, right? So this idea of sustainability in construction started way back in the 60s with activism. People understanding that we need to be environmentally conscious and we need to do better than we have been with regard to the consumption of natural resources and energy. And then it moved to standardization, prescriptive standards, if you will. And that's where LEED sort of led the way and said, if you do this, you should get that. And those have sometimes worked and sometimes they haven't. And then it started shifting. We see performance-based goals like the Living Building Challenge and Passive House and Reset Air. And these guys are saying, okay, we need to get the buildings to perform to these levels by whatever threshold or metric you have. What's changing right now, and it's changing very rapidly. It took us from the 1960s probably through the better part of the 90s to get from activism to standards. And then it took us maybe 10 years to get to performance, and it's taking us maybe 2 or 3 years now to getting to accountability. When you look at places like New York City and they have climate action goals, they've set their standards around building performance and they don't care how you get there. That's what's happening right now. And we're seeing that done with penalties. If you don't decarbonize your buildings and you don't reduce your energy consumption, the governmental agencies, city, state governments are now setting penalties for that. So we have to start looking at buildings from an accountability perspective. And that's where we have to use our tools in a different way to help us drive the building performance. It's not enough for us to design a high performance building. It's not enough for us to build a high performance building. We have to operate that high performance building. And that's where the market is going right now. That's
Hey, Craig,
our challenge. Yes, sir.
are you involved at all with those municipalities that you just rattled off that are really leading in this? How are you, the intersection of politics and science can be interesting, right? How are you able to participate or influence that?
So I am the board chair for the North American Passivhaus Network. We recently branded to the Passivhaus Network. We are the international NGO for Passive House in the United States. And yes, I am involved in those discussions. At our conference every year, we have a policy committee that is devoted to helping politicians and legislators understand building performance. Buildings use 47% of the energy in the United States today. 80% of the buildings that will exist in 1950 exist today, right now. We have to deal with the problem of climate change through buildings. We have to deal with the problems of COVID through buildings. And we have to understand that the existing building stock, we have to develop a solution for that because that's the biggest share of what we're dealing with today. So within my role of the North American Passivhaus Network on the board, we meet and we bring in legislators from all of these cities. You know, I'm proud to say NAPHN played a role in helping New York City draft this legislation. In Pittsburgh, the city of Pittsburgh now has a legislation for all its city-owned buildings have to be zero energy, and they're converting them right now. And we played a part in helping them understand how to do that. Everybody, even corporate America, wants to decarbonize, but they're not trusting the ways in which we've done it before, prescriptive-based standards. And they haven't really bought into yet the performance-based standards until they get a measurement verification system that shows them that they got what they paid for. So yeah, we see this as a macro trend. I don't necessarily think the governmental agencies are going to lead the way. I think the corporate America is leading the way. I think that you're seeing corporate America take a step forward, and hopefully the legislators will catch up soon because they haven't changed the building codes yet to get to these accountability standards. So with that, let's talk about how we do it. If I'm on a project team, I'm an owner or I'm an architect, an engineer, I get brought onto a team. How do we do that? Well, the first step is always setting your goals and targets, right? They have to be realistic and they have to be metric based. They cannot be aspirational. I've been on enough project teams by now where I've seen OPRs that are basically 50 pages deep, a lot of theory, a lot of language. We create them, we feel really good coming out of our meetings, and then we set them on a shelf and they collect us until the end of the project and we never come back to them. A really good OPR is done with metric based. Ours are typically one page. They are 11 by 17, but they're typically one page, and they're based on metrics. And we use them in our working document like a schedule is a working document. They get updated regularly. So when we hit hiccups on projects like schedule, like costs, like constraints on a project, we don't jettison the entire sustainability package and race back to code, which is legally the worst building you're allowed to build. We find a way to still meet our high performance goals, but meet the rest of the project constraints as well, like budget. And this starts with setting goals. And you'll see, we talk about this, creating an alignment, and then all of a sudden the project team brings its best experience and capabilities forward. When they're aligned, project teams really can solve problems. But this repeat down here, we've been on project teams where we get out of conceptual design and we're all aligned and we're all marching in the right direction. And then we hit the end of SD and everybody starts to lose a little focus. And next thing you know, you're racing back to code, and that's the inertia. And we have to repeat and reset these goals to make sure everybody understands exactly where the project's going. This takes a really strong leadership, whether that's through the owner, through an owner's performance advocate, or through an architect. This requires a strong owner or leader to basically show the project team the way. And again, as I said before, the path to integration and alignment is technology. And when we talk about simulation, talk here for a second. So we talk about setting goals, right? We set goals to metrics, and then we create simulation, and those simulations prove through metrics whether or not we met those goals. It could be whole building consumption. It could be use for different factors of plug load, lighting load, HVAC. It could be through air quality, temperature, humidity, CO2. We set these to basically the same metrics, and we use simulation to determine whether or not we met those. And measurement performance, right? I want to create case studies to the meters and sensors in our buildings that connect back to the goals. If they don't connect to the goals, then we're really wasting our money because we have a meter or sensor that's telling us stuff that we really don't care about. We want to make sure that we connect the dots, and that's how we do this cost effectively on project teams. So the common thread through this pathway here is metrics. It's evidence-based criteria. So let's talk about that for a second. We can set our goals to certification programs, and they are all listed over here on the right, at least the most commonly used ones in the United States, or we could set them to metrics. And if you think about this and you look at, say, carbon dioxide, for example, well building will tell you 800 is the threshold for ppm on carbon dioxide. Reset Air is going to tell you 600 for high performance buildings and 1,000 for standard buildings. LEED is going to tell you, I'm sorry, it's Green Globes is going to tell you 1,100. And again, why do I want a sustainable certification program to set my goals? They don't know our building. They don't know what we're going to do in that building. They don't know the use of the building. Our owners want to set their own goals. And then we want to figure out if we can then meet a program for sustainable certification. If we do it the other way, it's a lot like the tail leading the dog. And we don't want to just hang a bike rack for a plaque when it doesn't necessarily align with our project-based goals. So this is where it starts. It starts with looking and recognizing the metrics within all the programs and then setting our own metrics that are job specific for us. Now I say job specific because we can have an owner that has multiple buildings, and based on use, these thresholds can change, right? We don't necessarily have to have the greatest thermal comfort values in a warehouse, right? So we might set our goals differently depending on the use for the buildings. And what you'll notice in a good OPR is they're separated by all of the performance elements of a building. I can't fit the entire OPR on this page, but you're seeing a simple cut of some of this. We talk about energy, we talk about indoor air quality, we talk about indoor environmental quality. The difference between IAQ and IEQ is the elements of light and sound. Then we talk about materials for both toxicity and embodied energy. We get after every single performance threshold, and we look to see if we can set performance-based goals on those. And this begins the process of then engaging in the right simulated environment and then engaging in the right measurement verification environment. And again, we find ourselves aligning, realigning, and realigning, and realigning. We do this at least 3 times on larger type projects with pre-construction.
Craig, do you find that you might start out with an owner who has performance goals or deemed to thought of as performance goals, and after a couple conversations or reiterations, they might change them in a good way? Meaning, you might say, hey, based on what you're looking at, maybe we need to go down this path. Is there a guidance that you're going to give as well to that customer in terms of what those performance goals can be?
Yeah, absolutely. A lot of times those goals are built around certification standards, but there are owners now who are starting to develop their own goals, especially when it comes to energy. So we're starting to see that. And then right now with COVID in that macro trend, we're starting to see owners set goals around ventilation strategies and how do we get at hygienic ventilation in buildings so we never breathe the same air twice and we can get at healthy buildings. And again, there is a synergy in what this happens. I'm going to drop back a few slides. So when you look at this, Passive House is really an envelope first strategy. An envelope first strategy with a thermal barrier that is very efficient and an air barrier. Well, if I have an air barrier, now all of a sudden I can get at indoor air quality, which is what Reset Air focuses on, because I don't have infiltration and exfiltration. I've eliminated that. Now the air is coming through the ductwork that I plan with the filters that I plan, and it gets at. So you can get at a win-win-win situation by simply looking through these standards and figuring out what works best for the buildings. So yes, sometimes owners have legitimate financial reasons for doing certification programs because money is tied to it. Sometimes they do it because of inertia, it's just what they're used to. And sometimes they figured out, well, wait a second, those aren't always working and maybe we have to set other goals. And that's where COVID is really making us look at ventilation and it's looking at air quality totally different than we used to. So yeah, absolutely. But again, we're getting at now that we've set our goals, we want to start simulating. So when we talk about simulation, we're talking about physics-based whole building modeling. We've standardized around an IES VE system, but there's lots of programs out there that can support this. But this has to be done iteratively. The difference between what we're talking about and what has been done in the past is that we typically get to the end of definable features of work like SD and DD and CD, and then we hand the drawings to our simulators and we hand the drawings to our estimators. Report back, tell me where you guys are at. And that doesn't necessarily work because we hope to fix our problems in the next phase and we don't always get there. So what we talk about is in early SD, we're talking about massing and orientation. In an existing building, you might not have much of that opportunity, but you can look at window to wall ratio, you can look at shading devices, and then you get at wall optimizations, and then you get to systems. We want to solve those three problems, at least with big strokes in SD, so that by the time we get into DD, now we're talking about refinement, but we're designing on the fly with the architects and engineers so that we can answer those questions as they come up. This prevents rework and it helps us move a lot faster through projects. And then simulation. So this is an example. I mean, people may think simulation is something we can't always do on buildings. Typically, it's been done transactionally. We get our loads, we size our equipment, we're done simulating. And what we argue is we should be repurposing the simulation and using it straight through the end of design all the way through construction. We keep reinforming our simulation with QA/QC during construction processes because we want to use that model in operation. We're talking about an operational building energy model. And the only way to get there is to continue to model with the project team straight through the project. We can do this for all forms of projects, multifamily, retail, commercial, hospitals. This works for all forms of buildings. In estimating, we talked about in terms of doing iterative estimating, and I just show this slide here. This is a single line item on a very detailed estimate, but we're talking about a unit price estimate. When architects are making decisions or engineers are making decisions, they don't want to see a square foot estimate or a CSI estimate with lump sums because they can't make decisions. When you see, say, an 07 package for insulation and you don't understand, is this interior insulation? Is this in the exterior wall? Is this bats? Is this rigid? What insulation are we talking about? They need to be able to see within these models how much it is, where it's at, and what does it cost. So as we iterate that model, we may be able to go back to them and say, look, we can reduce 2 inches of insulation on your wall if we put a little more insulation in your roof, right? There's 8 dowels, and we could change one dowel and move another dowel. This gives the architects the ability to start seeing where are my stat points and where can I start to look at opportunities to save money. This is how we can deliver high performance projects at par. And there's a lot of data on that, by the way, that we can share if anyone's interested. So again, we're building use cases to connect our measurement verification system back to our OPR so that we can understand whether or not very quickly if we've won or lost. And this is a quick case study. I know we're getting to the tail end, Marcy, but I wanted to show a quick case study. We went into this project here for the East Liberty Presbyterian Church. It's a 80-year-old, 85-year-old cathedral. The building has never gone through a renovation since it was built, and the owners of the pastors and the membership, they were finding themselves not using spaces because they became too hot and cold, and they asked us to come in and take a look at the building. So we worked with them to basically set our strategy. We used the passive house strategy. We weren't able to go to passive house criteria because the envelope is limestone inside and out, but we were able to seal up all of its windows and make sure the rest of the building was sealed. We did a blower door test on this entire building, and for this size, it was probably the largest blower door I participated in so far. And we set our energy goals using energy modeling. We were able to meet the 2030 challenge with this building, and this building is the first cathedral in the world that is Reset Air certified. And then they had set a bunch of other goals around thermal comfort that we were able to help them realize as well. This is a smart building, and it uses simulation. It uses simulation in this building. So we have whole building energy meters. We have for all forms of energy and water. We have sub-meters for lighting and mechanical systems. And we have this building is deployed with, I think, 10 Reset Air sensors, which is what it needed to become Reset Air certified. So it is a smart building. It's tracking and trending its data. If these guys can do it, anyone can do it. And I give the example of this model because if you look at this model, this is one of the most complex models we've ever done. It only took us about 2 weeks, so it's not magnitudely more expensive, but I just want to show it in terms of complexity. You know, simulation exists today and the technology exists to model very sophisticated buildings. And this is East Liberty, and this is how we're starting to track. So you'll notice in here, we have 3 things that track with East Liberty, right? We have meters, we have simulation, and we have invoices, and we track all 3. And then we can set up notifications when we start missing our parameters and targets. We could do this all the way down to the 15-minute interval. So when you hear about fault detection and diagnostic, you hear about analytics for buildings. These guys are using all those analytics as part of the strategy to optimize its operations. So the point I want to make here is that when you use building science and you use it in conjunction with data science or smart buildings, it gives you the ability to operate these buildings for 50 years, for the life cycle of the building. And that's where it makes all the difference on existing buildings. And if you have a building like ELPC, where they were turning off fans to save energy, which sacrificed indoor air quality, they now have a building that's fully operational in terms of its ventilation, heating, and cooling strategies, and they're Reset Air certified, and they're meeting their 2030 challenge goals with respect to energy. So the UN SDGs talks a lot about this stuff, and the common thread through here is the reduction of fuel poverty, improving of health through indoor air quality, and combating climate change. This is what we're talking about, and these are the major goals that we have on every single project we touch for an existing building. These are the 3 goals that commonly raise to the top, like the cream and coffee. It just always comes to the top. And whether or not we can layer in other performance-related goals just becomes a part of the owner's requirements when they develop their OPR and their goals and targets for the building. So we can start getting after, once we solve this problem, we can get after water, we can get after light, we can get after sound, we can get after all of the other important factors for high performance buildings.
Hey, Craig, all incredibly compelling. What are the objections you hear, right? When, you know, my God, who wouldn't do this, right?
Right.
What are the objections that you typically need to overcome?
I would argue that it's not so much objections. Nobody is going to sit in a room when we talk about this and say, no, that's bad. That's the bad direction to go in. What we combat against most is inertia. The inertia from, oh my God, this is going to cost so much money. How are we going to be able to afford this? Or, oh my gosh, we've been doing it this way for so long. How do we get away from doing it this way? And we have to sit down and we have to talk to them about the performance and why that matters the most. We come at it from an energy perspective only because of climate change and where the current legislation is starting to move. But getting at the delta of energy is 1/10 of where the value is at in these existing buildings. 90% of the value in these existing buildings is people. So when you start thinking about that and you think about high performance building and how does that impact people, the next phase of what you're going to see in the next few years is us talking about presenteeism, absenteeism, healthcare costs, churn rate of employees and retention rate of employees, and health and happiness. That's where the macro environment is headed right now. But if you don't fix your operational carbon, then it's going to be extremely challenging, or you're going to pay a premium to deal with the occupant benefit, right? Because we have to basically plow more air, which means I'm spending a lot more money on my mechanical systems to make sure that the building operates at an exceptional level. If you take an envelope first approach, you reduce your loads, the mechanical systems become smaller, more affordable for life cycle and operational costs, and we get at building occupant benefit much quicker and easier.
Do you have any tips or tricks you can share about how do you get people to move off inertia then, right? Very powerful, the do nothing theme. Like, how do you nudge them? Because right, it's hard to go from inertia to, oh, I'm going to do everything. How do you just get them moving a little bit?
You show them an example of a project. So if you have someone that's a developer in commercial office building space, we walk them into one of our passive houses for commercial office buildings. And if you've never been in a passive house, and that's the spectrum on high performance building, you know, if you want to ask, what's the most high performance building I can build? The answer is passive house based on building science, because it identifies the inflection point on when insulation stops paying in a wall, and it gets you down to that 14 EUI. So what we do is we typically will take them into a project and say, listen, have you ever been in a passive house? And if you haven't ever been in a passive house, I would suggest strongly find one in your neighborhood and go in and look at it. It's the differences between looking at black and white TV and HD. You know, when you think about sound, and you can literally, I can feel it when I walk into one of those buildings. It's sound. You can feel the indoor air quality in terms of, you know, there is no TVOC, there is no particulate matter in the air. It's extremely clean air. And the acoustics in a passive house are just amazing. We had a bus literally right out front of the front door in one of the buildings we were in. We couldn't see it, we couldn't feel it. And if we didn't see it, we'd never know it was moving in front of the building.
And you couldn't smell the exhaust either, so that's good.
So Craig, you would take that prospective client and host them at perhaps one of your other customers, and you think it's just that apparent when you walk in. An hour or two later, you're like, I guess that was we're talking earlier about your 3 monitors. You either get it or you don't. But if you bring them in, but if you feel it's that apparent, if you bring them into an existing facility like that, they'll understand before they leave.
Yeah, the idea of passive house, and I don't want to focus on passive house because there's a lot of clients that really don't want to pay for the certification, but they want the high performance building. So we always talk about it in terms of high performance buildings, and then there's a spectrum to that, right? So what I would suggest, if anyone is interested in pursuing high performance buildings, we can demonstrate, or there exists topologies for every single use of a passive house. We can show it to you in a grocery store, which has high process load. We can show it to you in a hospital. We can show it to you through commercial office buildings, multi-purposes, all the way down to single family. Now, we don't practice in single family, but we can certainly show that to you. Even high schools, and high schools are the best place because when you start thinking about those occupants, I mean, you're talking about students in a learning environment. There's no one that benefits more from being in a high performance building than students in a learning environment. We see a lot of those projects going on right now.
So we did have a couple questions that came in. One of them, and Craig, you mentioned this already, we need to start with the enclosure, right? We need to look at the efficiency of that existing enclosure. Where do you find that most owners want to spend their time considering those performance goals in the beginning? Like what are they most concerned with, it appears, up front?
Well, I mean, the mechanical industry has been telling owners for the last 10 years that envelopes don't pay, and we know they do. When you think about insulation is always cheaper than systems. When I reduce the loads and I can get to a smaller snap point on my systems, then I can save a lot of money, not just in operational costs, but in life cycle costs. So for us, it's talking about the owners in terms of not passive house, but high performance buildings as natural order of sustainability. So let's think about this, and it's logical. And if you talk to anyone who's been in construction for 5 seconds, they immediately get it. What's the natural order of sustainability? It's the concept of passive first, active second, and renewable last. Passive first. I want to create a envelope that is thermally efficient, has an air barrier, and it's balanced, right? All my fenestration, all my connectivity from wall to slabs, wall to roof, it's all basically done in a way that's connected. It's like a thermos. I put coffee into the thermos, I put a lid on it. 2 days later, I take the lid off and steam comes out. Why does steam come out? Well, because it has nowhere to go. That's a passive house. It keeps its energy. When we go to active second, you're talking about decoupling HVAC systems, right? So the HVAC manufacturers will tell you, well, we make the best box in the world, and this is the most efficient box to put on the roof. We want to make that box go away. So we talk about decoupling. We use different strategies to separate ventilation from heating and cooling. So now all of a sudden we can do a DOAS or an ERV solution, which is dedicated ventilation, with a highly efficient energy recovery core. And we don't pay a penalty on those systems when they run because they're so efficient. Then I deal with my heating and cooling. In our climate zone of Cleveland and Western Pennsylvania, heating isn't really the issue for us, right? We can get away with very, very little heating requirements. It's cooling. Cooling becomes the issue. But in a passive house, your loads are so low, you can bring into the discussion now VRF or air source heat pump systems, because while they may be unaffordable at high loads because of a lot of cassettes, at low loads, I can use them now because they become much more affordable and they are super efficient. So now we start looking at alternative strategies for dealing with that in an active solution. And renewables last. Why do we talk about renewables last? Because I want my photovoltaic array to be this big and not this big, right? And if I do step 1 right and I do step 2 right, then my renewable strategy will actually fit on my roof. In our current market right now, when owners and clients reach for renewable first strategies, A, can't fit them on the roof and still zero out. B, you can't afford them because they're too big. C, you can't afford them when they break because they're too expensive. Renewables are awesome and they're great, and that's where the world's going, but we have to keep an eye to how do we use our renewables. We need to use an efficiency first strategy, and then we can offset. If we start to offset first, and at any time if we violate the natural order sustainability, we will pay a premium. But if we do it right going in and we set our goals the right way, we can do this at par. And we are seeing passive house projects, and I have blogs all over my website on it from data. We're seeing passive house projects going up at par all over the country right now for practitioners who've done it a few times and understand how they're doing it.
That's great. That's great information. So a couple other questions came in. When you're talking to different organizations, how many times do they actually have performance goals? Do they most likely have them, or are they think they have performance goals?
Well, code is a performance goal, right? So even if you don't have a goal, you have a goal. And there are clients are changing. It depends really kind of who you're talking to. Our clientele has become very sophisticated, and our clientele is coming to us and raising the bar on goals on every project we touch with them, because they understand it's really free money, right? It's free capabilities if you do it right. So they're the ones pushing the envelope for us, but for our purposes, it's going to them and saying, listen, if you're Fortune 500 or corporate America and you've set corporate decarbonization goals, how are your facility managers actually achieving those? We have the solution through this envelope first strategy. If you're government and you're trying to figure out how do we get at decarbonization and reaching our climate action goals, then we can work with them to, again, educate them around envelope first strategies and why they're the best strategies in the world if you want to pursue this. And I could tell you guys right now, Europe leads the world in this discussion. They are killing us in terms of what they're able to do versus what we've done in terms of building stock. And like it or not, Canada is way far ahead of us. Canada is very, very far ahead, not as far as Europe, but they're way out there in terms of climate or carbon reductions within their building stock. The United States is starting to pick up steam because energy is becoming more expensive, and we're starting to figure out there's a better way. So as soon as we figure it out, we'll leapfrog that, but right now we're not leading that discussion.
So to just kind of a final thought, I guess, as we look at these simulations, as we look at these performance goals, do you have like a final thought, final recommendation, something you want to share to kind of close us off today?
Yeah, I think that the message that I'm offering today for the team is that we can transform existing buildings. We can make them into high performance buildings. And when we do, there's a ton of value that comes out of that process if you're a building owner or if you're an architect or engineer. And we can do that without paying a premium. If we respect triggers of life cycle, deferred maintenance, natural renovations, we can set a master plan in a building. So as we do our renovations, we're renovating the right way. We have to stop thinking about building performance in an incremental way. Incremental management does not work, because what happens when my boiler breaks? I replace it in kind, right? Or I buy a more efficient boiler, but it's still a big boiler. I want to reduce the loads on that boiler. So when my windows expire, I want to put in better windows, or when I'm renovating a space, I want to increase my thermal barrier and air barrier. We cannot poke and hope our way through this. Buildings are too complex. And I've been doing this for 25 years and I can't poke and hope my way through this. We have to build a simulation for our buildings and understand what our low energy opportunities are for each of these buildings. And then once we have that master plan, then we simply execute it, which becomes a lot easier. So we have to think up front. We have to think before we start engaging. We can't react and simply do business as usual and expect to change the consumption of buildings. It's just never going to happen. And in the way we do this, it's no different than the processes you have now. We're not arguing that you should spend more money. You have an MEP that's basically going to run a model to size their equipment. Why not run that model early, use it to make better decisions, and create an open environment like a BIM, right? So BIM has a BIM execution plan, which means that that's open. Architects share their BIM. And when they share it, we're using it for clash reporting, you're using it for submittals, you're using it for schedules, you're using it for facility management software programs. We're repurposing that BIM and using it in so many different ways today than we did even a few years ago. Our argument is, why are we not doing the same thing with BEM, building energy models? We should create an open execution plan, create it early, use it to make better decisions, give it to the MEP and let them run their loads on it. It's the one model. We should only pay for it once, and the owner should own it, and the owner should be able to use it to its benefit. But that's not what we're doing today. We get out on a project, we let the MEPs run the model, transactionally select their units, they discard the model, and the owner's sitting there without the value that they just paid for. And to us, that's kind of crazy. It's not logical.
Well, Craig, thanks for joining us. The book is The Power of Existing Buildings. My coworker just sent a message. Artie Molinari said loves the book, so he read it without us even telling him to read it. So that's awesome. But you know, there is so much that I think we can do as an organization, and I know that as soon as Craig said he loves air barriers, I immediately, had to talk to him. So
absolutely, you guys have all the great toys, and not only that. When we get into and we create our envelopes, what I love most about Tremco is you can work with us to basically check for wall durability. And there's a lot of times that architects don't have the in-house capabilities to do that. So reaching out to a manufacturer like Tremco, where we can check thermal bridge analysis and hydrothermals to make sure our walls are durable, is huge. And I want to make sure that everybody understands that that's a resource that we scream from the mountaintops on. And I love the fact that you guys do that. And I hope everybody takes note and uses that service with you guys.
I know there'll be a lot more to come. Looking forward to working with you more, Craig. So thank you so much for being on our program today.
Thank you, Craig.
Thank you both. And I really appreciate the opportunity to speak to your group. If anyone has any questions, Marcy, you have the deck. Please feel free to share it with the community. And if anyone has any questions, feel free to reach out. We're more than happy to show you examples of anything you guys saw today.
Perfect. Okay. Thanks, Craig. Thanks, everybody. Have a great weekend.
You too. Thank you so much.